Let's look at what we mean by monotonic sequences. We say that a sequence is monotonic if its terms are non-decreasing or non-increasing. So basically you can line them up and they're always getting bigger or they're always getting smaller. To show if a sequence is monotonic, you usually come and you look at the a sub n term and compare it to the a sub n plus 1. Now clearly this is an increasing, non-decreasing sequence, or we'll eventually call this increasing, or the opposite. So let's look to see if this sequence is monotonic. This sequence, remember, is 2, 4, 2, 4. Okay, now it bounces between two values, and if you pick any two values, then clearly this is not monotonic, because 4, you cannot say this right here one way or the other. So this is not monotonic. What about this sequence right here? If b sub n is 2n divided by 1 plus n, what I need to show is, does 2n divided by 1 plus n. Now I'm thinking it's increasing, so let's see if that's less than 2 n plus 1 divided by 1 plus n plus 1. We're just going to see, is this a true statement or isn't it? Well, let me rewrite this as 2n divided by 1 plus n. Is this, and I can have that equal sign, 2n plus 2 divided by, and this is n plus 2. Now these are positive, so I can cross multiply. So 2n, n plus 2, is this less than or equal to 2n plus 2 times n plus 1? Is this a true statement? Well, let me multiply this out. This is 4n plus 2n squared. Is that less than or equal to 2n squared to 2 plus 4n plus 2. Let's see, the 2n squares go away, 4n goes away, so I'm left with is 2 always greater than or equal to 0, and the answer is yes. So this is monotonic. Now, what about this one right here? C sub n is n squared divided by 2n minus 1. You can look at the n plus 1 divided by, or the n plus 1 in the nth term. That's going to be a little bit complicated. All right. Oops, messed that up. Got carried away. Started doing the other side first. Sorry about that. Okay, I can do this, but I'm not going to be able to solve this very easily. It's going to be a really ugly mess. So instead, let me list out the terms. All right, so for n equals 1, it's 1 squared divided by 2 to the 1 minus 1. 2 squared divided by 2 to the 2 minus 1. 3 squared divided by 2 cubed minus 1. 4 squared divided by 2 to the 4th minus 1. Okay, so this is 1 divided by, let's see, 2 to the 1 minus 1 is 1. 2 squared is 4. Divided by 4 minus 1 is 3. So it looks like it's monotonic so far. 3 squared, so this is 9. Divided by 8. Okay, 16. Ew. Well, yeah, this is no longer in any way true. because this is greater than 1, these are less than 1. So this is not monotonic. Now, if we throw out the first term, we do wind up with monotonic sequence, but the sequence itself is not, because all of the terms do not fall into the monotonic format.